Have you ever really stopped to think about what's actually going on with electricity? The stuff that powers, well, everything.
It's everywhere, isn't it? You click a switch, light comes on, plug something in, it works.
Exactly. It feels almost like magic. But like, what is it deep down? And magnets too, the ones on the fridge.
Yeah.
Or the ones that make motors spin.
Yeah. Are they just separate things doing their own thing?
Well, today we're going to dig into that. There's this really deep connection, actually. A kind of dance between electricity and magnetism that's, well, it's the foundation for almost all our tech.
We're talking about electromagnetism.
Precisely. And for this deep dive, we're drawing on some really interesting stuff from a book called John Genia Guy.
Which translates roughly to Beginner's First Steps in Electricity by Jan.
Right. And it's written specifically for, total beginners, people who might look at wiring diagrams and just feel completely lost.
So the goal is to make it accessible.
Yeah, our mission today is to kind of demystify electromagnetism, break it down from that beginner's viewpoint. So hopefully you walk away feeling like you really get it, even if electronics isn't your thing.
Okay, sounds good. It's fundamental stuff, but definitely often misunderstood.
So let's unpack this. Okay, imagine you're starting out. You want to learn about electrical engineering. Maybe you sign up for a university course. What do you think is the very first, like the absolute rock bottom basic subject they teach you? Before the complex circuits, before power stations, what's ground zero?
That's a really good starting point. You might guess it's something immediately practical, right?
Yeah, like wiring a plug or something.
Or maybe electrical machinery.
Yeah.
Generators, transformers, motors, big stuff.
Or even circuit theory, how electricity flows.
Exactly. And look, all of those are super important. Absolutely vital, no question. But the source material, this book, it's really clear. The one subject that's truly foundational, the must-have course, is electromagnetism.
Electromagnetism. In Korean, Genjagihak.
Right. And it's the field that looks at the source and the phenomena of both electricity and magnetism, what they are, how they work, and crucially, how they interact.
Okay, so it's the bedrock.
Yeah.
But what's interesting, especially since this book is for beginners, is what the author says about their first time encountering it.
Oh, yeah. What was their experience?
They basically say it was incredibly hard, really challenging, took up a ton of time, loads of effort.
Sounds familiar for a lot of engineering students.
Totally. And they mentioned it being very, very mathematical, which made it hard to really grasp the core ideas, the concepts underneath the numbers.
Abstract stuff.
Yeah, they even admit to feeling sleepy in class. And, looking over at other students, the smart ones who seem to just get it, wide awake and taking notes.
Right, that feeling of everyone else understands this but me.
Exactly. And it just shows that even for someone who ends up writing a book explaining this stuff, that initial struggle is, well, it's pretty normal.
It really is. It's like learning a completely new language, almost. The grammar, the rules. It takes time for it to click.
So what's fascinating then is why? If it's so tough, why is it the fundamental course?
Well, that's the paradox, isn't it? The author's struggle highlights why it's so crucial, that hard work wading through the math and the abstract ideas.
Yeah.
It's necessary because you're building the absolute foundation for everything else. It's not just about facts. It's about changing how you see energy and forces interacting.
Oh, okay. So it's challenging because it's fundamental.
Pretty much. You're learning that things you thought were separate are actually, deeply linked. And that can be a bit mind-bending at first, especially for a beginner.
So let's connect the dots. Why put students through this? What's the big payoff, the aha moment that makes all that hard work, those sleepy lectures, worthwhile?
Well, the author describes that exact moment. As they got further into their studies, it suddenly clicked.
What clicked?
Those tough, basic concepts about electricity and magnetism. They realized that was the perfect explanation for how even a simple electric circuit creates a magnetic field.
So the theory suddenly explains something practical.
Exactly. It wasn't just equations on a page anymore. It was the key to understanding how things actually work in the real world. Like why an electromagnet picks up metal, or how a speaker cone moves.
Right, that makes sense. It's like trying to understand how a car engine works without knowing about combustion or pistons. You can drive the car, but you don't really get it.
Perfect analogy. And grasping these core electromagnetic principles is absolutely vital if you want to really understand and work with all the applied stuff.
Stuff we use every day. Like transformers.
Definitely. Transformers are key for power distribution, changing voltages up or down so electricity can travel long distances efficiently and then be safe to use in your home.
Okay. And generators.
Generators, too. Essentially big spinning magnets converting movement into electricity. That's how we get power for cities.
And motors. The opposite.
Right. Taking electricity and turning it back into motion. Think electric cars, washing machines, fans. Countless things. You need electromagnetism to understand why they work, not just that they work.
So this isn't just for engineers. It's kind of the beginner's key to how the modern world is actually wired.
If we zoom out a bit, it just hammers home that you absolutely cannot talk about the basics of electricity without also talking about magnetism. They're inseparable.
Two sides of the same coin.
Exactly. At the most fundamental level of how power works, they're intertwined. Moving electric charges, they make magnetic fields.
And moving magnets.
Moving magnets, or even just changing a magnetic field, can create an electric current. It's this constant back and forth, this interaction.
That's the core dance you mentioned.
It is. And it's not just neat physics. It's literally what makes almost everything technological run.
Okay, this is where it gets really cool, I think. Taking a step back into history a bit.
Right, because it wasn't always obvious they were connected.
Not at all. For centuries, people thought electricity and magnetism were totally separate things, just two different forces of nature.
You had static electricity, like lightning or rubbing amber, and then you had magnets, like lodestones pointing north. Unrelated.
No connection seen at all. They were just different phenomena.
But then things started changing, especially in the 19th century. A lot of scientific breakthroughs happened then.
So people started noticing things.
Yeah, kind of by accident at first. There was this Danish physicist, Hans Christian Ørsted, back in 1820.
Okay. What did he find?
He noticed that when he ran an electric current through a wire, it actually made a nearby compass needle move.
Whoa. So electricity was creating magnetism.
Exactly. That was huge, a direct link. Then about 10 years later, Michael Faraday, an English scientist, showed it worked the other way too.
So magnetism could create electricity.
Right. He found that moving a magnet near a wire or changing the magnetic field around it could induce an electric current in the wire.
That sounds like the basis for it.
For the electric generator, that discovery literally powers our world today. Suddenly, these two separate forces look like, well, maybe they weren't so separate after all.
A massive shift in thinking.
Absolutely revolutionary. It set the stage for so much.
And then came the person who really put it all together, right? Formalized it.
James Clerk Maxwell, a Scottish physicist, lived from 1831 to 1879.
So what did Maxwell do that was so groundbreaking? He didn't discover the effects. Ørsted and Faraday did that.
True, but Maxwell's genius was in the mathematics. He took all these observations, all these connections, and he unified them.
Wow.
He created a set of equations, now famously known as Maxwell's equations. They are like the fundamental rules of electromagnetism.
Okay, so math that describes how it all works.
Precisely. They describe how electric and magnetic fields are created, how they interact, how they travel, and here's the amazing part.
Yeah.
From his equations alone, Maxwell predicted that there should be waves made of oscillating electric and magnetic fields, electromagnetic waves.
He predicted waves.
Yes. And he calculated their speed. And guess what speed he got?
Uh-oh. Let me guess. The speed of light.
Bingo. The speed of light, which led him to the incredible realization that light itself is an electromagnetic wave.
Wow. Okay, that is huge. So light, radio waves, all that stuff.
All part of the same family. The electromagnetic spectrum, it all came out of his unified theory.
So the source material actually says that within electrical and electronic engineering, Maxwell is considered maybe even more important than Newton or Einstein.
That's what it suggests from that specific academic viewpoint. Newton gave us gravity. Einstein revolutionized space and time, absolutely fundamental work.
Right, icons.
But Maxwell gave us the language, the mathematical framework for basically all modern electronics, communications, power, everything that electrical engineers do. His unification had such a direct, practical impact on the field.
Which kind of makes you wonder, doesn't it, about the power of finding those underlying connections.
Definitely. When you unify things that seem separate, you often unlock completely new ways of understanding and manipulating the world.
So, let's bring it back. What does this journey mean for us? Trying to understand this from a beginner's point of view.
Well, we started with this subject, electromagnetism. That sounds intimidating, right? Something even the author struggled with in college.
Yeah, definitely sounded tough.
But we've seen how it went from being this difficult academic thing to being recognized as the absolute core, the foundation of all electrical engineering.
Understanding that link between electricity and magnetism. It's not just for PhDs.
Not at all. It's the key to understanding how nearly everything works. Your phone, the power grid, medical imaging. It all relies on manipulating electromagnetic fields based on the principles Maxwell laid out.
It kind of demystifies the magic we started with.
It does. It shows the underlying dance, the fundamental principles that make it all possible.
And grasping those principles, even at a basic level like the book aims for, really empowers you.
Absolutely. It reinforces just how powerful understanding the fundamentals can be. When you get the why behind something complex, you can start to make sense of the applications, the real-world stuff.
It's not just knowing that the light switch works, but having some idea how it works based on these deep connections.
Exactly. It makes technology understandable, maybe even more amazing when you appreciate the science behind it.
Which leads to a final thought, maybe something for you, the listener, to ponder.
Okay.
We just talked about how electricity and magnetism were seen as totally separate for ages, until Maxwell unified them, leading to incredible breakthroughs.
Right. A unified theory changed everything.
So the question is, what other things in our world, maybe in science, maybe in society, maybe even in our own lives, seem totally separate right now?
Things we treat as distinct categories.
Yeah, but maybe they're actually deeply interconnected, just waiting for their own Maxwell moment, waiting for someone to find the underlying unity that unlocks a whole new level of understanding.
That's a fascinating question. Like, maybe the connection between, say, gut health and mental health, or economic systems and environmental impact, things we often discuss in isolation.
Could be anything, really. Personal relationships, global politics. Where are the hidden connections we're missing? Where's the next great unification waiting to happen?
Something to think about. The universe might be a lot more interconnected than we realize.
Indeed. Well, that's our deep dive for today. We hope you enjoyed exploring the surprisingly intertwined world of electricity and magnetism with us.